Assalamu alaikum, my name is Ayila Naeem and here is my lab report of digital signal processing, lab manual number 5, representation of discrete time digital signals into frequency domain. In task number 1, which is make your own my discrete Fourier transform and my inverse discrete Fourier transform for calculating discrete Fourier transform and its inverse using the above given formulas. This is the formula and here are some values x1, x2 and x3 and x4. Now rewrite the code in MATLAB, which is my discrete Fourier transform is given as this and my inverse discrete Fourier transform is given as this. For example, like for x1 value is given in the question. X1 is equals to my discrete Fourier transform and reconstructed x1 is equals to my inverse discrete Fourier transform. Display the original version of x1 and reconstructed the original version of x1. For x2, same as for x1, same as for x3 and same as for x4, and the output is this. For x1 the original signal is 2 3 4 5. Discrete Fourier transform of x1 is 14 and 0.000 inverse and minus 2 plus 0.000 inverse, and the reconstructed signal of x1 is 2 3 4 5. The original signal of x2 is 2589. The discrete Fourier transform of x2 is given and reconstructed x2 is also 2589, same as x3 and x4. In task number 2, which is frequency resolution can be enhanced by adding trailing zeros. Calculate DFT for following signals and observe the change in the frequency spectrum. So the values are given from x1 to x11. In MATLAB, define the my discrete Fourier transform function. The signal values are given in the question. Calculate the my discrete Fourier transform for each signal and display the frequency spectrum for each signal. Like this: display frequency spectrum for x1, display absolute x1, displays frequency spectrum for x2, display x2, and display x3, display x4, and so on up to x11. And the output of these signals is given. The frequency spectrum for x1 is 14, 2.82, 2.22000 and 2.8284. This is the output of code number 2. And in task 3, use of MATLAB built-in functions. Let we have an arbitrary signal x1 and x is equals to FFT, x is equals to this is the value. Now put this function in MATLAB. So the given signal is x is equals to 1 2 3 and 4. Calculate the discrete Fourier transform. X is equals to FFTX, extracting the real and imaginary parts of frequency spectrum, which is x real is equals to real x and x imaginary is equals to imaginary x. Extracting the magnitude of frequency spectrum, x magnitude is equals to absolute of x, and extracting the phase angle of frequency spectrum, which is x angle is equals to at and second x imaginary and x real. Inverse discrete Fourier transform to time domain representation is given in the code. Now the output of this function is this. The original signal is 1 2 3 and 1 2 3 4. The discrete Fourier transform of the function is given, and the real part of frequency spectrum, imaginary part of frequency spectrum, magnitude of frequency spectrum, phase angle of frequency spectrum, and inverse discrete time Fourier of two time domain. In task number 4, calculate DFT and plot magnitude spectrum, phase spectrum, and power spectrum for signals in the task to observe the effect of zero padding. In this task, we calculate 3 spectrums, like magnitude spectrum, phase spectrum, and power spectrum for each signals, and observe the zero padding. So the signals are given from x1 to x11. Function to calculate and plot spectrum. Calculate and plot spectrum for x1, calculate and plot spectrum for x2, and so on up to x11. The functions to calculate and plot spectrum is function calculate and plot spectrum x and title. Calculate the discrete Fourier transform, which is x is equals to FFTX. Extract relevant information. N is equals to length n, and f is equals to 0 ratio n minus 1 multiply by 1 divided by n, which is the frequency vector. This is the frequency vector, and calculate the magnitude spectrum. Magnitude spectrum is equals to absolute x. Calculate phase spectrum, calculate the power spectrum by given the formulas, and plot the magnitude spectrum. Give them type term, x label, y label, plot phase spectrum, plot power spectrum, and the output of the resulting code is this. This is the original signal of magnitude spectrum, original signal of phase spectrum, and original signal of power spectrum. And this is the zero padded signal of magnitude spectrum, zero padded signal of phase spectrum, and the zero padded signal of power spectrum. And also the zero padded signal of magnitude spectrum when n is equals to 16. In the above, zero padded signal is given when n is equals to 8, and in this when n is equals to 16. Same as magnitude spectrum, phase spectrum, and power spectrum. This is the original signal for x4. This is the original signal for x5, x6, x7, x11, and up to x10, x11. So this is my lab report of DSP. Thank you so much for watching my video.